UAM, uniformly accelerated motion. On a side note, I cannot spell. It is a problem that I have. I am not good at it. I've tried for decades to increase my ability to spell, and I'm just not good at it. I play Scrabble with my wife. This helps me to learn to spell, even though I lose. It's okay, okay? I bring this up because for 5 years, I spelled the word uniformly incorrectly in uniformly accelerated motion. And more than 1,000 students went through me in that time, and not a single one mentioned that I was spelling uniformly incorrectly. Would you agree that there's a good chance that at least one of those students noticed? Okay? Please, if I spell something wrong, tell me. I'll go, and then I'll say, thank you very much for telling me that I spelled it wrong, because it irks me, but I like to know, because I like to try to figure it out. I have equilibrium. I'm going to write it all sorts of different times. Every time I have it in my lecture notes, I have to identify how many L's, because I cannot remember. I think it's 1, but right now I'm not sure. Okay? Okay, buses. How many S's in buses? Is it 2 or 3?
3.
2.
You can spell it either way.
What?
That's right.
B-U-S-E-S, kisses.
No.
Yeah.
You could spell buses either way. It means the same thing. Same thing with
buses with 3 S's means kisses. Buses with 2 S's is vehicles.
no, they're both the same thing. Kind of like traveled. You could spell traveled with 1 L or 2 L's.
In what language?
In English. This is the English language. All right, we're gonna look into this one. I'm not gonna do it right now.
Because I remember learning it when I was little.
Okay, I look forward to figuring out that I'm wrong. That's fine. We'll do it. That's fine. Not right now. Okay, so at this time, we're going to talk about uniformly accelerated motion, UAM. I'm interested. Okay, here we go. UAM, uniformly accelerated motion. What this means is, just so you know, I spelled it with an A-L-L-Y, uniformly. It's uniformly. Okay, UAM. This means that the acceleration is uniform. The acceleration is constant. It means that the acceleration equals a number. There are all sorts of examples of uniformly accelerated motion. If you slam on your brakes in a car, if you put your foot down on the accelerator of a car, if you roll down a hill, if you jump out of a plane, if I were to launch you using a giant slingshot, these are all examples of uniformly accelerated motion. We're going to do many, many different examples. I am about to write down the equations for uniformly accelerated motion. Then I'm going to put a box around them. Then I'm going to read them again. Here we go. Velocity final equals velocity initial plus the acceleration times the change in time. The change in x, the displacement, is equal to the velocity initial times the change in time plus 1/2 times the acceleration times the change in time squared. The velocity final squared is equal to the velocity initial squared plus 2 times the acceleration times the displacement in the x direction. And lastly, the displacement in the x direction is equal to 1/2 times the velocity final plus the velocity initial times delta t. Giant box. I will read them again. Velocity final equals velocity initial plus acceleration times change in time. Change in x, the displacement, is equal to the velocity initial times the change in time plus 1/2 times the acceleration times the change in time squared. Velocity final squared equals velocity initial squared plus 2 times the displacement in the x direction. The displacement in the x direction equals 1/2 times the velocity final plus the velocity initial, that quantity, multiplied by the change in time. The UAM equations. Let's work with them. Austin, please tell me what are the variables in these 4 equations. There are uniform variables, so tell me what the variables are.
Velocity.
Which one? We're listing all the variables that are in these equations. So velocity.
Velocity final.
And?
Velocity initial.
Keep going.
Acceleration.
Acceleration.
Change in time.
Change in time. And?
Change in x. Or change in
Delta x, actually change in position, or delta x, or displacement. X stands for position. So we have velocity final, velocity initial, acceleration, change in time, and the displacement in the x direction, change in x. Those are the 5 variables in here. There are 4 UAM equations. When you use these equations, you should use meters and seconds. It's about 95% true that you have to use meters and seconds. It's about 100% true that you can use meters and seconds when you solve these problems. So there's a small amount of times where you don't have to, but if you do use meters and seconds, you will almost, I can't think of a time when you won't do it correctly. So please make sure you use meters and seconds. Now, there are, if you know 3 of the variables, you can find the other 2. So here's how it works, class. Class, there are how many UAM variables? Try that again. Class, there are how many UAM variables?
5.
There are how many UAM equations?
4.
If you know how many of the variables,
3.
you can figure out the other.
2.
This leaves you with 1. No, there can be more than one answer. 1 happy physics student, so close. We'll do it again. Class, there are how many variables?
5.
How many equations?
4.
If you know how many of the variables,
3.
you can figure out the other.
2.
This leaves you with 1
Happy
happy physics student. Good. All right.